even though they don't have the example. What's going to happen here is we're going to solve these equations, and only the ones that are circled are going to use your calculator. The rest of them, you have to use your special triangles or the values that we looked at the end of class on Friday with 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. So a little review first of what we did at the end of last class. At the end of last class, we drew the graphs of sine and cosine. We actually only drew up to 360 degrees, and we labeled these points going up to 1 and down to -1. We did that by using the definition that cos is x over the radius, sine is y over the radius, and tan is y over x. And we looked at these points because sine, cos, and tan do exist when you can't draw a triangle. So for example, if I draw a point at 1, 0, and I draw an angle in standard position, I get an angle of 0. And it's very hard to draw a triangle where one of the angles is 0 degrees. Same thing, it's very hard to draw a triangle when one of the other angles, other than the 90 degrees, is another 90 degrees. Could you draw a right angle triangle with two 90-degree triangles? Two 90-degree angles. That would be very hard to do. And yet, sine, cos, and tan exist for these. So on this assignment, okay, you're going to have to show your work. For number 1 and for number 2, these are ones that you're first going to say, you have to recognize when you can't draw a triangle. So if sine of theta is equal to 0, as a fraction, that would be 0 over 1. Your opposite side would be 0, your hypotenuse would be 1. You can't draw that triangle. On the ones that you can't draw a triangle, you're going to have to look at your graphs or the chart that we just had, and this chart is on page, I'll pull it up here. This chart was on page 444. And I think on page 444, we used the graphs. We drew the graphs as well. So on the ones that you can't draw the triangle, you need to use your graph. The graph of sine is on this page. The graph of cosine you should have drawn on page 444. If I have sine equal to 0.
Pardon the interruption. There was none that came down for the question of the day. The answer is 250. Wow.
I thought it was 2,500. All right. So, if no triangle can be drawn, use the graph. We need sine theta equal to 0. So I go on here. Where's my y-coordinate equal to 0? At 0, 180, and 360. But in questions 1 through 10, they just say solve between 0 and 180. So you're just looking from here to here. For questions 1 through 10, you're looking for all answers for questions 10, 11 through 20. So when it says sine theta equals 0, you would just say, I'm going to use my graph. Theta is equal to 0 degrees and 180 degrees. You would do the same thing for question number 2. For question number 3, in question number 3 we have sine theta equals negative This one, you can draw a triangle with the opposite side being 1 and the hypotenuse being 2. But you have to find out where that triangle is going to be. According to the cast rule, if sine is negative, it's not in quadrant 1, and it's not in quadrant 2. And so what I want you to do to show your work for question 3 is I want you to draw an angle in quadrant 3 and draw an angle in quadrant 4. And in both of these, label your reference angle and label the angle in standard position. Next, after you've drawn it, you have to figure out what your reference angle is. And this is a non-calculator one. So you have to go to your special triangles and see where on the special triangles is sine of theta 1 over 2. So on our special triangles, we had this triangle for 60 degrees and 30 degrees. This is one of the triangles you have to have memorized. So can you see that sine of 30 degrees opposite over hypotenuse is 1/2? So our reference angle would be 30 degrees. Then your answers for this one in quadrant 3, the angle theta, I'll switch to green. My green angle theta in quadrant 3 would be 180 plus 30 degrees, 210 degrees. And in quadrant 4, it would be 360 minus 30 degrees, 330 degrees. But for questions 1 through 10, they just wanted you to say answers between 0 and 180. How many of our answers were between 0 and 180? None. So this one has no solution. Maybe you want to clarify for yourself. Between 0 degrees and 180 degrees. So we are going to have questions that require you to know your special triangles. This is one of them. You see the 1/2, you have to know that your reference angle, that belongs to the 30-degree. And once you have that, then you can use your pictures, right? When I draw my triangles, they're always back to the nearest x-axis so that they include your reference angle. And again, the reason we're having this assignment is because this is super important, not only for grade 11 this year, but you use it all again next year in grade 12. So if you learn this really well now, it's also going to help you whether you're taking grade 12 next semester or next year. Okay? We're going to do one. So this question 3 is an example where you could use your special triangles. Question 4 is a special triangle one, but first you'd have to divide both sides by 2 to get the cos theta by itself, and then see which triangle it belongs to. Question number 5 is the first one that's circled with a calculator. We'll do one calculator, one together. So in question number 5, first thing you're going to do is you're going to get the cos theta by itself by dividing both sides by 5. So we get cos theta equals 4/5. That is not one of the ratios that you have memorized. So the ones that you have memorized, you have to be able to recognize them. And the easiest way to recognize them is they'll come up on the non-calculator part of your quiz or test. So you're like, ooh, I don't have a calculator, so it must be one of my special triangles. But this one would be on the calculator part of your test. First of all, you would notice that according to your CAST rule, cos is positive. That happens in quadrant 1 and 4, not in quadrant 2 and 3. So then you could go and draw an angle in quadrant 1, label your reference angle, and in quadrant 4, label your reference angle. Your actual angle then will be exactly the same in quadrant 1, and this will be the angle in standard position in quadrant 4. And you can draw a triangle back to the nearest x-axis, and you would know that you could label on this triangle, since cos is adjacent over hypotenuse, you would know this side is 4, this side is 5, this side is 4, this side is 5. Now that we've drawn our triangles, you can find that reference angle using grade 10 trig, right? I would know that cos of my reference angle is adjacent over hypotenuse 4/5, so I could find my reference angle by doing cos inverse of 4/5. Go to my calculator. And I get 36.9 degrees. Then my actual angle, switch to green here so we can keep it color-coded. Well, in quadrant 1, it's going to be 36.9 degrees. And in quadrant 4, I would do 360 minus 36.9 and get 323.1. Did this ask us to round to something in particular? No. Okay? Now that I found all of my answers, remember that question 1 to 10 said just list the answers between 0 and 180. So did we get any answers between 0 and 180? Yes. This one is good, and this one, it's a right answer, but not where they wanted us to look. So the answer will just be 36.9. This is also one of the things that gets a little bit complicated when you get into grade 12, is they switch up the domain, which are your x values or theta values that we're solving for, right? So it's good practice in 1 to 10, still find them all, but then just list the ones between 0 and 180, and then in 11 through 20, you're going to list them all, okay? So this is an example of a calculator question, but most of these get you to practice your memorized ones. Where do we get some complicated ones? Once you get to 11, you're going to have to factor using your quadratic equations. So you can, here, should we do one factoring one together? So if we look at number 11, sine squared plus 2 sine theta minus 3. So just like regular factoring with x squared plus 2x minus 3, if you wanted to get a sine squared, just like if you wanted to get an x squared, does it make sense that the only way to get sine squared in factoring would be sine theta times sine theta? And to get 3 would have to be 3 and 1. Now to get a minus 3, one of them is going to be positive and one of them is going to be negative. And we need, when we FOIL this out or multiply this out, we need plus 2 sine theta. So I would need that to be positive, so I have plus 3 sine theta, and this to be negative, so I'm subtracting 1 sine theta to give me plus 2 sine theta. Once it's factored, you would split it up. And here, you'd get sine theta equals -3. And here, you would get sine theta equals 1. I'm going to make these into fractions, because the next step is drawing our triangles. Can you draw a triangle where the opposite side is 3 and the hypotenuse is 1? No. Does this match up on our chart or on our graph? Is there a spot on our graph where sine is equal to -3? Well, -3 is -1 is here, -2, -3. If you went across, can you see that that never hits your graph? Okay? So when we get questions, this is actually a great one to do. When we get questions where the opposite over hypotenuse is bigger than 1 or bigger than -1, positive or negative, doesn't matter, we can right away, without a calculator, say that this is not possible. One over 1, this also can't be drawn as a triangle. You can't have the opposite side 1, but the hypotenuse being 1. But this one, if we look at our graph, is something that we can see. When is sine equal to 1 on our graph? It's at 90 degrees. So when you get 0, 1, or -1, those ones you can use your graph and do it without a calculator. If you get a ratio or a fraction where it's bigger than 1, like 3 over 1, then it will always be not possible. So this is a hand-in assignment for tomorrow, but we are going to take about 20, 25 minutes right now to work on it.